Welcome to Tennessee's at-home learning series for math. Today's lesson is for all our sixth graders out there. All children are welcome to tune in. This lesson is the 18th in our series. My name is Reggie Caruth, and I'm an assistant principal here in Tennessee Schools, and I'm so happy to be your teacher for today's lesson. Welcome to my virtual classroom. If you haven't seen any of our previous lessons, you can find them on the Tennessee Department of Education's website at www.tn.gov/education. You can still tune in to today's lesson, though it may be more fun to go back and see previous lessons since we may be talking about things previously learned today. So today we'll be learning about finding the area of trapezoids in mathematics. Before we get started, to participate fully, you'll need the following for today's lesson: paper and pencil and a calculator if you have one. Y'all ready? Let's begin. So I can't wait for us to dive into our lesson today as we continue to work with area of special quadrilaterals. Let's start out by warming up our brains and getting our brains going for today's lesson. All right, so to get started, look at the two given figures. What geometric shapes are we given? Correct, we have a rectangle and a triangle. So I want you to find the area of each shape. Let's see how you did. So I know that the area of a rectangle is area equals length times width. My length is what? 3 inches times 4. 3 times 4 is 12. So my area is 12 inches squared, or square inches. So the area of a triangle is area equals 1/2 base times height. So I'm dropping down on 1/2. I'm gonna substitute my base for 4. Good job. My height for 3. Good job. 1/2 times 4 is 2. 2 times 3 is 6. So the area of this triangle is 6 what? Inches squared. So what operation would you use to find the total area of both shapes? Correct, I would use addition. So if I know the area of this shape is 12 inches squared, plus the area of this shape, which is 6 inches squared, total area is going to be 18 inches squared. Good job. What do you notice about the trapezoid? Good, a trapezoid is a quadrilateral, which tells us it has how many sides? Correct, it has 4 sides. A trapezoid also has one pair of parallel sides called the bases. Yes, it looks like a combination of triangles and rectangles. Remember, we can describe this as composed of triangles and rectangles. You first worked with trapezoids in 1st grade. You remember that? That seemed like forever ago. So at that time, you worked with shapes such as trapezoids to create a composite shape to make a new shape. Remember composites? We're going to do something similar today to determine how to find the area of a trapezoid. So to do this, let's start with the parallelogram. All right, so here is our parallelogram. What did we determine in the earlier lesson that we can use to find the area of a parallelogram? Yes, we said that the area of a parallelogram is found the same way that we find the area of a rectangle. So can we find the product of the base and the height? So area equals base times height for the area of a parallelogram. Remember that the height is the length of the segment that forms a 90-degree angle or is perpendicular with the base and it extends to the opposite side. Let's see how that can help us find the area of a trapezoid. We can carefully divide the given parallelogram into two equal trapezoids. So here, I can divide this into the two equal trapezoids that's here. So what do you see? I see that one trapezoid is half of a parallelogram. So any parallelogram can be divided into two trapezoids with one pair of parallel sides that are also the same shape and size. Here are a few examples. Let's try to find the area of the given trapezoids using the fact that the trapezoid is half of the parallelogram. You can use a calculator if needed. So we're going to look at the first one. We're going to call this one example 1. To find the area of the entire parallelogram, what do we do first? Yes, we can multiply the base times the height. What is the base in this trapezoid? Correct, 3 inches. I heard 9 inches and I heard 12 inches. Look carefully at the parallelogram. What is the length of the total base? The length of the total base would be 9 plus 3. So if I take this 9, move this piece over here to do plus 3 inches, will be 12. Great job. So what is the height of the parallelogram? Good, it is 8 inches. So the area, to find the area of this parallelogram, is A equals B times H, or base times height. I know that my base is what? 12 inches, because I'm taking this piece and this piece, add them together. And my height is 8. So this gives me the area of the parallelogram to be 96 inches squared, or square inches. So now that we have this, is this the area of the trapezoid? You're correct. Since the trapezoid is half the parallelogram, I can take half and multiply it by 96. So I can take 1/2 and multiply it by 96 to give me an area of what? 48 inches squared. So my trapezoid area is 48 inches squared. Good job. Let's look at the second one. So I'm going to call this one example 2. What is the base and the height of the entire parallelogram? I'm going to divide this because I kind of wrote sloppy. All right, so I heard someone say the height is 5 1/4 inch, and I agree. So the height, I know for this one, 5 1/4 inch. So what about my base? What would be my base of this entire parallelogram? Correct. I know that this part of my base is 8.5 inches. This part of my base is 3.5. And if I add them together, it's going to give me the entire base of my parallelogram, which is what? 12 inches. So using the base and the height, we can find the area of the entire parallelogram now. So going to my formula, area equals base times height. I know that my base was 12 inches. My height is 5 1/4. So now I can go ahead and multiply. I'm going to do 12 times, I'm going to turn this into an improper fraction. 5 1/4 as an improper fraction is going to be 21/4. So now I can multiply these together. I remember from previous lessons, I can multiply my numerators, 12 times 21, and my denominators, 1 times 4. That's going to give me 252 over 4, or 63. When I divide that, that'll give me 63. Am I done? Not yet. I got to make sure I put inches. What does this 63 inches represent? This is the area of my parallelogram. So now I need to find the area of my trapezoid. So again, a trapezoid is half of that. So I can take 63 and multiply that by what? 1/2. So 1/2 times 63 is going to give me the area of my trapezoid is being 31.5 inches squared. Good job. Let's look at the last example. Example 3. All right, so since I copied this example 3 down wrong, we're going to go on and we're going to keep going from there. Y'all ready? Stay with me. Here we go. How would you summarize what we just did? Let's try it together. For each example, the sum of the bases of the trapezoid, we will call them base 1 and base 2, form the base of a parallelogram. So again, base 1 and base 2 from our trapezoids come together to form the base of our parallelogram. The area of each trapezoid is half the area of a parallelogram. Let's look at trapezoids and how they connect to other polygons. And take a moment to look at each and find the triangles and rectangles. Do you see the rectangles and triangles? Let's see how we can use this information to help us find the area. We will use these given triangles in a few problems to build our knowledge of finding the area of trapezoids by decomposing them into triangles and other shapes. So good job at looking at this. So here's our first problem. I want you to find the area of the given trapezoid by decomposing the triangles and other shapes. So let's decompose this together. So I know that I have my right triangle and I have my rectangle when I decompose them. This is 5 centimeters. My height of this one is 3 centimeters. Since I know that this total line is 9, if I take away this 5, this part is left to be what? We're going to find out. But I also know that this is 3 centimeters. So again, we can see all the dimensions for the two shapes except the base of the triangle. Does anybody know what the base of the triangle is equal to? Correct, 4 centimeters, based off of what we talked about earlier. So since this is 9, and I know this part is 5, that means this part of this will be 5 centimeters, which means this has to be 4 centimeters. Good job. So let's find the area of the two figures. How do we find the area of a triangle? Correct, the area of a triangle is 1/2 times the base times the height. So let's start substituting. What's my base? 4. What's my height? 3. So now I can multiply. 1/2 times 4, which is going to give me 2. 2 times 3 is going to give me 6. So the area of this triangle is 6 centimeters squared. So now how do we find the area of the rectangle? Good job. I heard somebody say area equals base times height. So let's start substituting. My base is 5. My height is 3. So I multiply 5 times 3. That's going to give me 15 centimeters squared. But what is this problem asking us to find? We're looking for the area of the given trapezoid. So we need to add the areas together to get the area of the trapezoid. So I'm going to add the area of my triangle, the area of my rectangle, together to get me the area of my trapezoid is, correct, 21 centimeters squared. Good job. Not too bad, huh? Let's look at another one. This problem says, Mr. Desmond, has tables in his office with tops shaped like trapezoids. The diagram shows the dimensions of each tabletop. What is the area of each tabletop? So look carefully at Mr. Desmond's tabletop. How can we decompose the tabletop into triangles and other shapes? You're right, we can decompose into 2 triangles and a rectangle. So take a moment to decompose and I'll wait for you. All right, so did you notice that the 2 triangles are the same size? So when I decompose, my 2 triangles, if I were to really cut those, remember it's not going to be perfect, are the same size. Since they are the same size, we can find the area of one of them and then double it to represent both triangles. So let's start off with decomposing the rectangle. So what is the area of my rectangle? Area equals base times height. So what's length times width. So what's my length? 0.6. What's my width? Times 0.9. So now I can multiply these together to get the area of my rectangle to be 0.54 meters squared. Good job. What about the triangles? What are the base and the height of those? Good. Some of you noticed that the height is the same height as the rectangle. So my height, 0.6. What about my base? Well, if the entire base is 1.6 meters, if the rectangle is 0.9 meters of that, how can we find the base of the triangle? Great thinking. Subtracting the 2. So I have 1.6 minus 0.9, and that's going to give me 0.7. We then need to have that to represent each triangle. So I'm going to multiply this by 1/2 because I need it to represent both triangles. So 1/2 times 0.7 is going to give me my 0.35. So this is so now that represented my base. So what is the formula to find an area of a triangle? Correct, it's area equals 1/2 base times height. I can start substituting what I know. 1/2, my base is 0.35. My height, 0.6. When I multiply these all together, that's going to give me as my area. So now, what is the problem asking us to do? The area of the tabletop. So how can we find this? Knowing that we have the area of our triangle, then the area of a rectangle, what do? Correct, we can add up every piece to do our area of our tabletop. So I know the area of this triangle was 0.105. The area of this rectangle, and the area of this triangle is what? So now I can add them all together. That's going to give me an answer of what for the tabletop? Good job. So this is my answer. Woo! Let's do one more, because I think we got this. I want you to find the area of the given trapezoid by decomposing it into triangles and other shapes. So how can we decompose this trapezoid into triangles and other shapes? Okay, good. I see that too. This one can be decomposed into 2 triangles. Good catch. Let's find the area. We have triangle A, B, C, and triangle A, C, D. Which one you want to start with? Okay, Harrison, we will start with triangle A, B, C. So I know that my base of this triangle is 8. What about my height? Correct, it's 5. So now I know my formula. Area equals 1/2 the base times the height. I can start substituting. So 1/2, I'm going to substitute 8 for B, and then substitute 5 for H. So now I can multiply to get 20 meters squared from my first triangle. So this first triangle area is 20 meters squared. Good job. So now let's look at our obtuse triangle. So what is our height? It is also 5. What is our base? It is 4. So now, knowing this, I can start plugging into the formula. A equals 1/2 base times height to now start solving. So I'm going to substitute my base for 4, my height for 5. When I multiply that all together, that's going to give me 10 meters squared for this area. Am I done? Not yet, because I have to find the area of the trapezoid. And I can do that by adding the area of my first triangle with the area of my second triangle. So 20 meters squared plus 10 meters squared for the total area will be what? 30 meters squared. Good job. Isn't it awesome to see what we've been learning in the last few lessons come together for the area of a trapezoid? So as we pull our learning for today together, we can see a common thread of understanding. We see that we can find the area of a trapezoid by using the relationship between a trapezoid and a triangle, a rectangle, and a parallelogram. You guys done great today. Let's work on two more where you're going to do most of the work, and we will come back together to discuss and compare. If you have a calculator, you may use it right now. So I want you to find the area of this trapezoid. I want you to write down all the information that you're given and start thinking of ways we can use this to find the area. All right, so the trapezoid decomposes into a rectangle and a triangle. The rectangle dimension is 5 feet and 5.5 feet. The triangle has a height of 5 feet. So I'm just going to write this over here because we know that these are parallel to each other. And so to find the base of that, I know that this whole thing is 6.5 feet. So I can subtract 5.5 from 6.5 to give me the height of 1 feet. So let's check to see how we are doing. I see that many of you have the same given information written down. Great job. Now, how can we use this information? Correct, I agree, Evan. We need to find the area of the rectangle and then the area of the triangle. So take a minute to do that and let's check our final answer. So I'm going to start off with the area of rectangle. Based off my information, I know that I'm going to take 5 times 5.5, and that's going to give me an area of the rectangle of being 27.5 feet squared, or square feet. So I know that that's 27.5. So now I'm going to find the area of my triangle. That is 1/2 times my base, which is 1, times my height, which is 5, which that's going to give me an area of 2.5 square feet, or feet squared. So now the total area for this trapezoid is what? Correct, I do 27.5 plus 2.5, which is going to give me my total area of 30 square feet, or feet squared. Good job. I'm so excited. You got this. I want you to do this one all on your own. I'll jump back, and in a moment, we'll check your progress. So do this one on your own, and then I'll jump in to check your progress. What is the area of the trapezoid decomposed by? Good, into triangles. So what shape can we decompose this trapezoid into? 2 triangles. So what are we given? Good, I heard Shannon say that the height of the triangle 1 is 18. So the height of triangle 1 is 18. So I'm going to label this T1. And I know that my height is 18. Do I know my base? Good, I heard Tim say that the base is 22. Make sure you put those units. So now to find the area of this triangle is triangle 1 is going to be area equals 1/2 times 18 times 22. That's going to give me an area of what? 198 meters squared. Good job. So now let's do triangle 2. Okay, good. The base of triangle 2 is 3. What's my height? Good, 18. So now, do the same thing, area 1/2 times 18 times 3. So the area of this is 27 meters squared. So now that I have that, I can find the area of my total trapezoid by adding my two areas together to give me an area of my trapezoid of being 225 meters squared. Good job, y'all. Great work. Today we reviewed how to find the area of trapezoids. I hope you're seeing some connections to the area of rectangles, parallelograms, and triangles. You sure did do a great job. After the video, you'll have some problems to practice on your own. I will show you those independent problems now, or you can find them on the Tennessee Department of Education's website at www.tn.gov/education under the student practice. Good luck and try your best. I really enjoyed reviewing areas of trapezoids with you today. Thank you for inviting me to your home. I look forward to seeing you in our next lesson at Tennessee's At Home Learning Series. Goodbye.